Okay, so this video is going to address lesson 6.4 in the Discovering Geometry book by Key Curriculum Press. And what we're dealing with here is proving circle conjectures. And this is case 1 in the discussion part of the lesson 6.4 before it gets to the exercises. And basically, this is a proof that we need to develop. And what we're given is this circle, O, identified by O next to the center point, has an inscribed angle, which is identified by ABC. And also it says, what we're also given is angle ABC is on the diameter BC. So BC is one side of the angle ABC. What I'm going to do is I'm going to write this proof in more of a linear way. This tends to be the traditional way most textbooks address proofs. And I'm only doing this instead of the flowchart way of developing a proof as this book does, just to give you another way of thinking about proofs, because many of you in class are pretty linear in your thinking, so this may help a little bit. And what I'm going to do is I'm going to think out loud, so that way maybe you can see what goes on inside a brain when they're trying to figure out how you go from one point, which is the given information, and you develop a proof that mathematically proves the truth of another point, which is the end point. We want to end up here. We want to end up being able to say for sure that the measurement of this angle right here, which is considered angle ABC, is always going to be half the measurement of arc AC when an inscribed angle has one side on the diameter. We will always find it true that this angle is half the measurement of this angle. That's what we want to prove. So in this way of proving, what I always do is I start off with the given information. I'm told that there's a circle O with an inscribed angle ABC, so I put that down. Circle O with inscribed angle ABC. That's given. The next thing I'm told is that angle ABC lies on the diameter of BC. So I write that, angle ABC on diameter BC, and that's given also. Now, how do I know what step to come up with next to be able to get to this final point of proving the measurement of that angle? Well, one thing that I might want to think about is whenever I'm trying to prove the measurement of an angle, it's very helpful to work with a triangle, and especially if I work with a triangle that has known measures of angles. And the kinds of triangles that we know the measurements of the angles of are things like isosceles triangles or some sort of a right triangle. It could be a 30, 60, 90 triangle. There's a whole variety of well, there's a few triangles that we know the measurements of in the given angles. So first thing I'm going to do is I'm going to look at this angle, inscribed angle, and see if I can somehow design a triangle that I can work with to come up with some different steps to my proof. So there's two ways I can develop a triangle. I could try to, I'm doing this in pencil so I can erase it later, hopefully you can see that, but I could try and connect A and C and make a triangle that way. Or another place where I can try and make a triangle is maybe I can make one going to the center point from the end of C. That might be a place to start. When I think about the two different angles here, two different triangles here, I need to think about which triangle might get me to the measurements of the angles inside quicker. I'm going to go with the second triangle that I made, which is the line that's drawn from the center point 0 to A, because there's something I'm seeing already that might help me figure out what the angles are, what the measurements of the angles are in this triangle. I see that I've just drawn a line segment from the center point to the circle, and in this triangle I happen to have another side that also is from the center point to the circle. So I already know something. I know that this side is congruent to this side because they're both radii of the circle. This is a radius and this is a radius of the circle, so they have to be equal. And I know it doesn't look like it because this is a very sloppy sketch of a circle, But we're given the information that circle O is a circle, so we know that. So I'm going to start off with that. I'm going to go ahead and write down something I've just discovered, that if I develop a triangle ABO, I know I'm going to have BO, that line segment, is going to be congruent to AO. And my reason that I know this is simply all radii of a circle are congruent. Okay, and you know what? I'm going to number my steps. Oops, I don't know if you can see this. I'm going to number my steps just so we can kind of keep in order here my reasoning with my steps. In fact, I better space this down. Okay, so there's step 4. All right, so now that I've proven that this BO and AO are congruent line segments, I can start working with that triangle. I now can say that triangle ABO is isosceles. And how do I know that? Because the definition of an isosceles triangle is that two sides are congruent. So I'm just going to put definition of isosceles, and I'm going to abbreviate here, triangle. Okay. So now now that I know I have an isosceles triangle there, and I have two congruent sides, obviously now I'm getting to the measurement of the angles, which is where I wanted to get to. So now I can prove that these the angle B is congruent to angle A.